Yes, my name is Engineer Professor Godswill Ofolagba of the Department of Electrical Electronics Engineering, Federal University of Petroleum Resources. I want to demonstrate to you our research work, which is titled Pressurized Water Micro-Turbine Electrical Power Generator for Domestic and Industrial Application. Now, I would take you through our research work. Now, what you see here, it's two of a 1,000 liters water tank connected through our penstock, which is 8 inches pipe, which conveys the water from the water tank down to our chamber, which is painted in green, where the water is pressurized. This is the chamber, as well as connecting that to our generator. Let me show you the alternator, which is the generator, and the specification of the generator. You could see here, this is a 3.5 kilowatts generator with all the requirements. I will take you through that as we test this project. Now let's look inside the chamber. The 8 inches pipe connected through an 2 inches pipe with its valve, and you have the turbine, the one then we also have four of the nozzles, which basically would pressurize the water and heat the turbine to rotate, which basically can be controlled via the valves. Those valves are in blue. Then we're going to see, when we practically demonstrate this, we're going to measure them through those instruments. We'll measure the voltage as well as the speed of the alternator. Now, let's see how this can be demonstrated. Yes, we have opened the valve. We could see that the turbine is rotating because of the pressurized water coming from the water that is already pressurized and heating the turbine that is coupled to our alternator or generator. Now, here we want to take the measurement of the speed of the alternator, which will give rise to the required voltage and power that will be generated. 931 RPM is the speed at which the alternator is rotating. Then we want to measure the voltage, and the voltage from the alternator is 130.5 volts. Now, that output voltage, let's test to see that this voltage can still be used to power appliances, like for instance our fan. Yes, that fan is being powered, as well as you could see a bulb. This is just a simple demonstration to show that power has been produced by this setup. Now, what we've seen this far, it's a demonstration of just a proof of concept of our research work, but I want to give a reason why the voltage is 130. You could see that from the nameplate, the RPM, it's just 1,000. Required is 1,500 RPM. But however, we measured only about 931 RPM. So further explanation will be given why the voltage is 130 in the course of this presentation. Now, taking you through again, we have the penstock connected through the water tank, taken to our chamber where the water is pressurized. Then the pressurized water is rotating our turbine, which is coupled to our alternator. Then the voltage is the power generated from the generator, which is used to power our appliances. I also want to introduce you